Welcome everyone. We are discussing simplification of inverse circular function into simplest form. Today I will discuss how to simplify inverse circular function by substitution method. So we need some suitable substitution. Look, if function is root over a square minus x square, I have already discussed it in finding limit by substitution. Root over a square minus x square, x equals to a sin theta or a cos theta. So if we put a sin theta, so a square common, 1 minus sin square, so a square cos square theta, that is a cos theta. Our main aim is to remove root over sin. So if it is a square plus x square, so x equals to a tan theta or a cos theta. Because 1 plus tan square theta, you get a formula sec square theta, 1 plus cos square theta, so cosec square theta. So if it is minus, then substitution is x equals to a sec theta or a cosec theta. Sec square theta minus 1 is tan square theta. And if it is a plus x by a minus x or reciprocal, a minus x, a plus x, that is a plus x and a minus x occur simultaneously, then transformation is x equals to a cos theta. So we have to remember it. And so we use this theorem, sin inverse sin theta equals to theta. Theta belongs to principal value. So similarly for this. So this is our working theorem. So consider problem number 1. Suppose this is y, tan inverse x by a square minus x square. So what is transformation? X equals to a sin theta, because it is a square minus x square. Now what is sin theta? Sin theta is x by a. Now what is theta? Sin inverse x by a. So we are finding theta in terms of original variable x. So now simplify. Y equals to tan inverse a sin theta by a square common 1 minus sin square. So finally you are getting tan inverse a sin theta by a cos theta. So tan inverse tan. So it is theta. If no condition is given, we suppose theta belongs to principal value. So here condition is given. So minus a less than x, less than x. So what is x? X is a sin theta less than a. So minus 1 less than sin theta less than 1. So minus pi by 2 less than theta less than pi by 2. That is theta belongs to principal value. Because in tan inverse, principal value belongs to minus pi by 2 to plus pi by 2. So we are getting theta. Now what is theta? Sin inverse x by 2. This is the simplified value. So y equals to sin inverse x by 2. Now, if you want to differentiate it, then look, the argument is very simple, x by a. And if you want to differentiate without using transformation or substitution, then argument is not simple one. So 1 by 1 plus x square ddx of argument. That is why we always use transformation if argument is not in simple form. So what is dy dx? So dy dx, if we want to find dy dx sine inverse, so 1 by root under 1 minus x square by a square into ddx of x by a. So finally you are getting a by a square minus x square into 1 by a. So 1 by root under a square minus x square. So this is our dy by dx. So use suitable transformation, then simplify. Now second one, exactly same, x equals to a tan theta. Now third one, suppose this one is y, tan inverse root under 1 plus x square minus 1 by x. So argument is not simple. So you have to simplify using transformation. So 1 plus x square. So suitable transformation is x equals to tan theta because a is 1. So what is transformation? Put x equals to tan theta. So what is theta? Theta is tan inverse x. Theta equals to tan inverse x. Now y equals to tan inverse 1 plus tan square theta minus 1 by tan theta. So tan inverse sec theta minus 1 by tan theta. So this is our first step, to remove root over. Then second aim is, it is tan inverse, to try to express this argument in terms of tan. So tan inverse 1 minus cos theta by sin theta. So writing in terms of sin and cos. So 2 sin square theta by 2 and sin theta is 2 sin theta by 2 cos theta by 2. You have to remember formula of multiple and submultiple angle for performing derivative of inverse circular function. So tan inverse tan theta by 2. So this is theta by 2. So no restriction is given. We suppose it is in principal value. So half tan inverse x. So what is the simplified form? Theta equals to half tan inverse x.